Hi everyone. Today's topic we have to discuss here Maclaurin series expansion. So this is a series expansion of some standard function is there. By using this Maclaurin series, we have to find series of some standard function. So that's why this is very important to understand what is a series and how to write the Maclaurin series expansion. So in this topic we covered introduction, definition and notation and problem is there. Now let me start Maclaurin series expansion. Okay, when you think about the series, you have to know how to write the series. So it is a summation of some terms, means some defined terms. So first of all, we see here what is a Maclaurin series expansion. Okay, so what is a Maclaurin series expansion? Okay, when we think about the series, there is some defined numbers, there is some defined terms, so addition in ascending order. So it is a very easy to understanding this series. So first of all, we see here statement of this Maclaurin series. So what is statement of this Maclaurin series? Let's see. If f of x be a given function of x which can be expanded in positive ascending order, means positive ascending integral powers of x. So where are the powers of x? Means x power 1, x power 2, x power 3 and x power n and so on. There is an infinite series. Okay, so then f of x can be written as this is f of 0 plus x into f dash of 0 plus x square divided by 2 factorial into f double dash of 0 plus x cube divided by 3 factorial into f triple dash of 0 plus and so on x raised to n upon n factorial into fn of 0 and plus and so on. We get infinite terms, right? So this expansion of the f of x is called as Maclaurin series expansion of f of x. So also if we put this in this above expansion or in this above series, y is equal to f of x, so we take the another form of the series, means this f of x can be written as y is equal to f of x, right? Means when we put y is equal to f of x, then this f of x becomes y, right? So is equal to y of 0, means here f of 0 plus x into y1 of 0, means the first derivative at 0. Okay, means first derivative of f of x plus x square divided by 2, y2 of 0 means second derivative of f of x at a point 0 plus x cube upon 3 factored into y cube of 0 means third derivative of f of 0 at a point 0 plus and so on. We have to getting here infinite terms, means if we take the nth term, so xn upon n factorial into yn of 0 means nth derivative of this f of x at a point 0 plus and so on. So this is very helpful to find out the some standard expansion series, means suppose we have to find out e to the power x series, so clearly you have to go this Maclaurin series. So it is very easy way to find out this series. Suppose you want to find series of sin x, so clearly you go to Maclaurin series formula. If you have to find cos x, means using this Maclaurin series expansion we have to obtain some standard expansion and some standard result of the function is there, right? Now we are going to discuss here next point, that is we take the some standard function and its expansion is there. So problem number first, we have to take some standard result is there first. So expand this e to the power x by Maclaurin series. Okay, for Maclaurin series expansion. So let's see how it will be start. Okay, now let me start how to write its a solution. Let's see, it is a very easy. Okay, so first of all, you know what is the f of x. F of x is given e to the power x, means when we write let y is equal to f of x, and this is nothing but this is e to the power x. That is clearly you know that this is y is equal to what is that e to the power x. You know also very well what is that yn means what is that here e to the power x, means nth derivative of e to the power x is e to the power x. And now there is another way you have to write y at a point 0, you will getting here e to the power 0, means x is 0, we are to getting here 1. And similarly if we taking nth derivative of at a point 0, means e to the power 0, that you will get here 1. Okay, means this is for all values of n. for all values of n. If you are to putting y1 of 0, your answer should be 1. If you are to putting y2 of 0, means second order derivative of f of x at a point 0, that is equal to 1. So this is for all n. I am writing here for commonly, this is for all n. Now we have to expand this term by using Maclaurin series. Then you know very well what is a Maclaurin series. So I am writing here, therefore by Maclaurin series. Maclaurin series expansion. So you know the Maclaurin series expansion in terms of y, it becomes y is equal to, that is a y of 0 plus y1 of, means I am writing here now in this way, y of 0, okay, means series expansion of y is equal to y of 0, this is x into y1 of 0 plus x square divided by 2 factorial into y2 of 0 plus x cube divided by 3 factorial into y3 of 0 plus and so on. If you write the nth term, that is x raised to n divided by n factorial into yn of 0, where y1 of 0, y2 of 0, y3 of 0, these are nth derivative of f of x at a point 0. These are nth derivative of f of x at a point 0. Clearly you have to already find out here yn of 0 is what, means now I am taking here y is nothing but this is y of 0. Okay, so y of 0 means what is that, here first term is getting here 1 plus next term x into y1 of 0. If yn nth derivative is e to the power 0 means 1, then it should be y1 is also 1, x into 1 plus next term we are going to discuss, that is x square divided by 2 factorial into y2 of 0 means again the value is 1 plus x cube divided by 3 factorial into this y3 of 0, means you are to getting again third derivative of this e to the power x at a point 0, that is equal to 1 plus and so on plus x raised to n divided by n factorial here into yn of 0, means again here 1 plus and so on. So clearly you know guys what is a y is equal to what is that, e to the power x, and therefore this is equal to 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial plus and so on plus nth term is x raised to n divided by n factorial plus and so on. We get the infinite series expansion is here. Okay, and this is your standard result, or this is your expansion of e to the power x, right? This is your result. Okay, now in this result you have to also remember that I am taking here some note or some remark is there. If this is for reference, this is equation 1. Okay, so if we put or if we replace x by minus x in 1, so what we will get here, e to the power minus x only is equal to, what is that, what is the expansion of now here, e to the power minus x. Now clearly you know very well e to the power minus x, x is replaced by minus x, so this is a 1, x is replaced by minus x, so minus x plus now this is x is replaced by minus x, and minus x square becomes is again x square divided by 2 factorial, then x cube, x is replaced by minus x, it will get minus x cube divided by 3 factorial, and next sign is what is that, plus and up to plus and so on, we get infinite series. Means if e to the power minus x, then the term are plus or minus alternately here. Okay, and also if we replace x by ax, so it will get very clearly e to the power what is that, ax is equal to 1 minus here is ax plus a square x square divided by what, 2 factorial minus x cube divided by 3 factorial, means plus ax is there. So I am writing here is only plus ax in what, equation 1. So all terms are plus guys, because of that e to the power plus ax. Okay, so this is a cube x cube upon 3 factorial plus and so on. Suppose you have to write nth term, so this is a raised to n x raised to n divided by n factorial, and now this is a series expansion of e to the power what is that, ax. Okay, so you have to find now guys this result, and your answer is this. Okay, this is your series expansion of e to the power x is there, right? Now we are going to discuss here next problem, that is problem number 2. Okay, so what is the problem here? Okay, so expand sine x, expand sine x. So what is the sine x? I called this is a sine series, sine series called as a sine series. Expand this sine x called as sine series. So by using Maclaurin's series. So clearly guys, you know that what is the solution or how to write solution. Clearly here given to you y is equal to f of x, and f of x it becomes sine of x. That is clearly y is equal to here sine of x. If y is a sine of x, then you have to find its a derivative. Okay, means its a derivative is what? Its a derivative is what? Means nth order derivative of, I am writing here yn. Okay, we already discussed here guys what is the nth order derivative of sin x. In successive differentiation, you know very well what is the nth derivative of transcendental function. So let's see, nth derivative of sin x is nothing but this is a sine of x plus, that is n pi divided by 2. This is a nth derivative of sine of x plus n pi by 2. Okay, this is for all values of n. This is for all values of n. Okay, if we substitute y1, it's your derivative is sine of x plus pi by 2. If we substitute y2, now this in this way. Okay, so I'm writing again y of 0. Y of 0 means here sine of 0, means this function y at a point 0, means replace here x by here 0, and you know very well what is the value of sine 0 is, what is that, 1. And also if you have to find yn at point 0, you will have to getting here sine of only here n pi divided by 2, sine of n pi divided by 2 only getting here, because x is 0. Okay, now you know clearly guys, if we putting the value of n is equal to 1 2 3 4, now here in this putting, okay, so let putting n is equal to here 1 2 3 4 and so on for all values of n. So we have to getting clearly what is a y1 of 0. Y1 of 0 means this is sine of 0, that you will get is equal to 1. Then if we putting y2 of 0, y2 of 0, y2 of 0 means here we have to substitute in this series yn of 0, means y2 of 0, it will get again n is equal to 0, means again here sine 0, sine 0, its value is becomes again 0, right? If we substitute y3, means n is equal to 3, then y3 of 0, so it will becomes value of here sine of 0, it again here minus 1, and you have to substitute here y4 of 0, so this will get again 0. If we substitute yn as y5, therefore y5 of 0, it will get 1, and so on and so on. So this is guys, this is y1 derivative, mean this is first derivative of this f of x at point 0 is 1, second derivative of f of x at point 0 is 0, third derivative of f of x at point 0 is minus 1, and so on you have to write here. So you know by Maclaurin series, so let we have Maclaurin series, Maclaurin's series or Maclaurin series expansion. So what is a Maclaurin series expansion guys here? So I'm writing here this is y is equal to what is that, y of 0 first plus x into y1 of 0 plus x square divided by 2 factorial into y2 of 0 plus x cube divided by 3 factorial into y3 of 0 plus and so on. In this way, this is Maclaurin series. So substitute y0, y1, y2 in above series. So number 1 here. So substituting the values of y1, y2, y3 and so on this in equation 1. So what we will get? Y means here guys, y means here simply sine x, and that is equal to, this is nothing but y of 0. Y of 0 clearly you have to getting that here. Clearly you see y of 0 is what is that? 1. So this is a 1 plus next term is what is that, y2 of 0. Y2 of 0, this becomes totally 0, means second term is a plus 0. Plus I am going to discuss here next term, third term, means y3 of 0. Y3 of 0 it will get means minus here x square into y3 of 0. So what will get now, this is x cube into y3 of 0, x cube upon here guys, 3 factorial into value is what is that, -1, right? Plus next, what is that next term, that is x4 upon 4 factorial into y4 of 0, that will becomes again 0, and you have to getting the next term is positive term, so you have to getting plus x raised to 5 divided by 5 factorial. Similarly, you have to getting the next term x raised to 7 divided by 7 factorial, plus and so on. Means what is that, you have to getting here sine x is equal to first term is what is that, here 1 into x is there, here 1 into x, so x minus x cube divided by here 3 factorial plus x raised to 5 upon 5 factorial minus x raised to 7 upon 7 factorial plus and so on. So this is called sine series expansion, right? This is called sine series because of that trigonometric ratio is sine is there, so that's why we called this is a sine series expansion of the given y is equal to f of x, right? Clear up to this, guys? This is very easy to understanding. What is expansion of sine x? It is x minus x cube upon 3 plus x raised to 5 upon 5 factorial. So power is equal to upon factorial. Suppose x raised to 5 upon 5 factorial minus x raised to 7 upon 7 factorial means here odd powers of x only in sine series, and you know that very clearly sine is also odd function, that's why odd powers are there. Okay, it is very too easy to understandable here. So this is all about problem number 2. Getting this, guys? Okay, now I am going to discuss here third problem, that is problem number 3. Here expand cos x is there, expand cos x. So how it will be expand, we call this is a cosine series. Okay, this is very easy understandable, guys. So let me start how to expand this series. Okay, so let you know that clearly y is equal to here cos of x. Okay, clearly y is equal to cos of x. You know, guys, its nth order derivative is what? I am taking its nth order derivative as yn is equal to, this is again cos of x plus n pi divided by 2, and this is for all values of n, right? So if you have to write now here, okay, suppose y of 0, what is y of 0 means cos of 0, and cos of 0, guys, you know very well what is the value of cos of 0 is 1, and yn of 0 means yn nth order derivative at x is equal to 0 means it becomes cos of it again n pi divided by 2, and this is for all n. So putting same thing is there, putting n is equal to what is that, 1 2 3 4 and so on. Means if we putting the values of 1 2 3 4 and so on, so what we'll have to getting here getting first order derivative at a point 0 means derivative of cos x at a point 0, that will becomes minus sin x, and minus sin x means minus sin x at 0, so sin 0 is the first derivative is what is that, here 1 is there. Okay, this is only, guys, it is very clearly if y is equal to 1 is there, if y is equal to yn means y1 of 0 means cos of 1 into pi by 2 means cos pi by 2 it becomes 1, cos 90 it becomes here 1. Next y2 of 0, so what will becomes y2 of 0 means 2 means cos pi is there, and cos pi you know very well this is a 0. y3 of 0 means 3 pi by 2 means cos of again 0, this is clearly 0. Then y4 of 0, you know, guys, this is also 0. So let's see y3 of 0. Okay, y3 of 0 means cos of 0, you know the guys, cos of 0 is a value is 1, but this is in third quadrant, that's why this is a minus 1 is there. Okay, similarly y5 of 0, what is the value of y5 of 0 means 5 divided by 2 means this lies in first quadrant, therefore this value is here 1 and so on. So clearly guys, now you know by Maclaurin series. So by Maclaurin's series expansion. So what is a Maclaurin series expansion? This is y, and y is equal to y of 0, right? Y is equal to here y of 0 plus what is that here, x into y1 of 0 plus x square divided by 2 factorial into y2 of 0 plus x cube divided by 3 factorial into y3 of 0 plus and so on. Substitute this value in this Maclaurin series. We have to getting that here y means here cos x, y means here cos x is equal to y of 0. Y of 0 means it is nothing but it is a 0. Y of 0, it is 0, means cos 0 is 0. So I am writing here the first term. So what is the first term here? Means y1 of 0, right? Y1 of 0. I am writing here the first term. So what is the first term? Let's see guys. This is y of 0. I am checking these values again because of that some minor mistakes is there. Let's see. Y1 of 0. Y1 of 0 means cos 0 here. Guys, you have to getting the value of cos 0 is a 0. Guys, you have to getting cos y2 of 0 is a minus 1. Y3 of 0 is 0. Y4 of 0 is 1. Right? So in this way and so on. Y5 of 0 here is 0 is there and so on. So guys, now I am writing here very clearly, putting this value in this equation. So what you are getting there, y of 0 means first term is what is that here 1 minus second term is absent. Now y2 means what is that, minus x square divided by 2, x square divided by 2 factorial into y2, that is minus 1, that's why minus is here. Now next term is what is that here, plus x cube term is absent because y3 is a 0. Now x raised to 4 term is there, means x raised to 4 divided by 4 factorial into y4 of 0, that value is 1. Now next term will be x raised to 6 divided by 6 factorial, and next term will be plus and so on. This is we get infinite series. So this series is known as cosine series. This series is known as cosine series expansion. This series is known as cosine series expansion, and this is all about guys expansion of cos x, right? This is a series of even powers of x only. Getting this guys? Let's see, I'm going to discuss here fourth problem on this Maclaurin's series. So it's a very easy guys. Now expand. My question is what? Expand 5 raised to x, the term as a 5 raised to x up to first 3 non-zero terms. First 3 non-zero terms of the series. Expand 5 raised to x up to first 3 non-zero terms of the series. You have to expand it simply guys by using Maclaurin series expansion. Let's see. Okay, let you know that what is f of x means function is given f of x is equal to 5 raised to x, and this is nothing but this is y. Okay, means y here 5 raised to x. So clearly you know guys expansion by Maclaurin series. Okay, you know guys by Maclaurin series. Okay, by Maclaurin's series. What is the formula for Maclaurin series guys? This is f of x is equal to, this is f of 0 plus x into f dash of 0 plus x square divided by 2 factorial into f double dash of 0 plus x cube divided by 3 factorial into f triple dash of 0 plus and so on guys. You have to getting this Maclaurin's series. Now you have to substitute here f of 0, f dash of 0, f double dash of 0 is what? Okay, for consideration I am taking this equation as 1 is here. Okay, now let's see. Let you know that again, let f of x is equal to, that is a 5 raised to x. F of x is equal to 5 raised to x. Guys, you tell me f dash of x is what? This is a 5 raised to x into log 5. This is 5 raised to x into log 5. Guys, you also tell me f double dash of x is what? This is a 5 raised to x again. This is a 5 raised to x again. Means I am writing here 5 raised to x again, and log of 5 it's a square, and log of 5 it's a square. Okay, clearly mentioned in the question, first three non-zero terms, so you have to getting these first three terms is there. Okay, so don't need to write the next term. Okay, or don't need to solve the next term, means what is the third derivative of x, don't write this here, guys. So from this we have to write f of 0 is what? Okay, so f of 0, guys, f of 0 is what? Means 5 raised to here 0. What you will get? Anything raised to 0 means here 1. So f dash of 0 is what? F dash of 0 is again 5 raised to 0 into log 5. So what you will get clearly here, guys? Log of 5. Okay, then f double dash of 0, guys, f double dash of 0 means here 5 raised to 0, and log 5 bracket power, means this is a square only, because you have to write for x is only 0. So 5 raised to 0 means becomes here 1, and log 5 it's a square is there, means the remaining is only log 5 it's a square as it is. Remaining is there log 5 and it's a bracket square is there. Okay, so let's see, guys, what we'll do here. So substituting this value in equation 1, I am writing here substituting in equation 1, in equation 1. So what we'll get, guys? This is f of x. Now you know very well f of x means what is that? It is a 5 raised to x, and that is equal to f of 0. F of 0 is value is what? 1, plus x into f dash of 0, the value is what? Log 5, plus next term x square divided by 2 into f double dash of 0 is a log 5 bracket square, plus and so on, guys, plus and so on. So clearly, guys, you know very well this can be also written as, this is 5 raised to x equal to 1 plus x into log 5. This can be also written as a plus x into log 5, x into log 5 bracket square divided by 2 factorial plus and so on. So this is called as exponential series expansion, or this is expansion of 5 raised to x. By using this expansion, you have to write expansion of, a raised to x here, means you have to calculate here 5 raised to x, also you have to calculate 3 raised to x here, you have to calculate also 10 raised to x is there. So this is your answer, or this is the result is there. Understood this? So this is expansion of 5 raised to x. This is very easy to understanding here, right? Now next example, guys, you see here, next, that is example number 5 I am discussing here. Okay, so if you have to given here x cube plus 2xy square minus y cube plus x minus 1, that is equal to 0, expand here, expand y in ascending powers of x, y in ascending powers of x, expand y in ascending powers of x. Then how to write the answer, or how to write the solution? Let's see, guys, how to write the solution. Now it is very clearly by Maclaurin series, you know that by Maclaurin's series, you know the series expansion of this is what? This is a y is equal to, I am writing here y is equal to, what is that? This is a y of 0 plus x into y1 of 0 plus x square divided by 2 factorial into y2 of 0, I am writing now guys here in this way. This is y2 of 0 plus and so on. This is a Maclaurin series expansion. But guys, here you have to given here, given, I am writing here given x cube plus 2xy square minus y cube plus x minus 1, that is equal to here 0. So putting x is equal to 0, we get y of 0 is minus 1. So this is y guys. Okay, so therefore put here x is equal to 0, we get, or we get, that implies we call that is a y of 0, we get here clearly minus 1 is there, right guys? Putting x is equal to 0, we get minus 1 is there. Y of 0 is what? Minus 1. So differentiating this equation 2, for consideration we call this is equation number 1, this is equation number 2. So now taking, I am differentiating equation 2 with respect to x. So what you will get taking differentiation of equation 2, x cube differentiation is a 3x square, right? Plus 2xy square differentiation is here only 2y, because y is a constant is there. 2y is 2y square, y square is a constant, plus here guys, that is again here you have to getting here 4xy y1, 4xy y1 means here you have to use a differentiation of product rule, means u into v, return the derivative of first y as it is and second y derivative x as it is, minus here 3y square y1, 3y square y1 getting, and plus y is equal to here 0. Because of that y1 it's the first derivative of y, and this y square is as it is there, so plus 1 is equal to 0. So guys, here also put x is equal to here again 0, so that we will get here y1 of 0, y1 of 0. So what you will get, the value of y1 of 0 is again taking 1 is there. If you have to simply substitute x is equal to 0, we are getting y1 of x, again differentiating 1. Okay, so again differentiating 1 with respect to x. Okay, if you taking again differentiating 1, so it will have to get, that is a 6x square plus 4y y1, 6x square plus 4y y1 plus here again 4y y1 plus 4x y1 square plus 4x y1 y2 is there, means 4x y y2. Okay, you have to use the product rule is here, and minus here 6y y1 square minus 3y square y2 is there. Okay, and that is equal to 0. This is a double differentiation of the equation 1. So putting here again, so put x is equal to 0, so what we will get here, y2 of 0 means second time differentiation, that's why y2 of 0, and y2 of 0 it get minus 2 divided by 3 and so on. I am writing here and so on, because of that we have to perform this operation repeatedly, so that's why I am taking here and so on. So what is the your next target is there, you have to substitute this value in equation number 1, means substitute y1 of 0, y2 of 0, means I am writing here substitute in equation number 1. Okay, substitute in equation number 1. So what is equation number 1 guys? Equation number 1 is y is equal to you have to write here y of 0. Y of 0 value is what? Minus 1 is there. Y of 0 value is what? Minus 1. So this will get a minus 1. Next value is a plus y1 of 0 means 1, that is remaining is only x. Next term is what is that here? Plus x square divided by 2 factorial into y2 of 0, it will get 2 divided by 3. Okay, and plus and so on. So we have to getting clearly guys, this is a minus 1 plus x minus x square divided by 2 factorial, and this is your answer. Okay, plus and so on, this is your answer guys. Okay, this is answer. Okay, this is all about example number 5. Now I am going to discuss here example number 6. Let's see example number 6. So what is the problem 6 is here? Here, if given is here, if what is that here? X is equal to, if x is equal to y minus y square by 2, that is y minus y square divided by 2 plus y cube divided by 3 minus y raised to 4 divided by 4 plus and so on. Prove that we have to prove here y is equal to, this is simply guys, this is x plus x square divided by 2 factorial is there plus x cube divided by 3 factorial plus x raised to 4 divided by 4 factorial plus and so on. We have to prove this guys, we have to prove this. So the proof is very easy guys. Okay, just you have to check whether y function is given is what and x function is given is what. So let clearly you know that how to write its solution. Let I am writing the term as, let x is equal to suppose log of x. X is equal to suppose log of x means can I write now this in this way? Let x is equal to, this is log of 1 plus y is there. Clearly x is equal to log of 1 plus y, so that implies 1 plus y is equal to 1 plus y is equal to e to the power x is there. Means taking logarithm on both sides, we have to getting 1 plus y is equal to e to the power x. Okay, so therefore clearly y is equal to what is that, e to the power x minus 1. And you know that guys very well, this is series expansion of, or this can be written as, this is x plus x square divided by 2 factorial plus x cube divided by 3 factorial plus x raised to 4 divided by 4 factorial plus and so on. So this is nothing but this is series expansion of what, x guys. Now conversely, okay, how to take conversely? If y is equal to what is that here, e to the power x minus 1. Okay, I'm writing here e to the power x minus 1 is there. Okay, so how it will be, right? Means e to the power x is equal to 1 plus y, so that implies e to the power x is equal to 1 plus y is there, right guys? So therefore x is equal to, again we have to write log of x plus, sorry, log of 1 plus y is there guys, log of 1 plus y. Okay, so therefore you know the series expansion of log of x is what, or log of y is what. So clearly guys, therefore you have to getting here x equals to, that is a y minus y square divided by 2 plus y cube divided by 3 minus y raised to 4 divided by 4 plus and so on. So this is a series expansion, means you have to getting this conversely two results is there. So this y is equal to in terms of x and x is equal to in terms of y. Hence the proof is there guys. Hence the proof. Okay. So this is all about the series expansion of Maclaurin or given series is there. Okay. So next example I am going to discuss here. Example number 7 is there. Okay. Show that cos square x is equal to 1 minus x square plus 1 by 3 x raised to 4 minus 2 upon 45 x raised to 6 there. We have to show that this guys. Then how it will be show? Let's see. The proof is very easy, very understandable guys. Let's see. Okay, so you know that cos square x is equal to, so formula is very easy. Cos square x is 1 by 2 in bracket 1 minus cos of 2x. Okay, cos of 2x. So this is nothing but this is 1 divided by 2 guys. Okay, now in bracket 1 minus, write the series expansion for cos of 2x. This is a 1, then plus, that is a 4. 2x means it becomes 4x square divided by what, 2 factorial, divided by what, 2 factorial minus 16x raised to 4 upon 4 factorial. Now this will get plus, 64x raised to 6 upon 6 factorial is there guys, and plus and so on. So after simplification we get 1 by 2 in bracket, or directly 1 by 2 inside the bracket multiply here, 1 by 2 inside the bracket multiply here, so we get the cos of x square. So therefore cos square of x is equal to, we'll have to getting clearly here 1 minus x plus 1 by 3 x raised to 4, 1 minus here x square guys, plus 1 by 3 x raised to 4 minus 2 upon 45 x raised to 6. You have to, after calculating the 6 factorial means 6 into 5 into 4 into 3 into 2, in this way you have to, after calculating this you have to getting this step, and for that result we have to use, which is the result, let's see guys, means you have to use the expansion of, let's see I'm writing here, okay, use expansion of here cos of x only guys, cos of x. So what will be the expansion of cos of x? In the last few minutes we discuss here expansion of cos of x, right, means cosine series. What is the cos of x? It becomes what is that here, 1 minus x square divided by 2 plus x raised to 4 divided by 4 factorial, here is a 2 factorial, minus here x raised to 6 upon 6 factorial is there guys, and plus and so on. Okay, you have to use this result, and using this result we write this step guys, okay, and hence the proof, hence the proof is there guys. Okay, this is all about Maclaurin series and its example. In this session we discuss here what is a Maclaurin series, how to denote the Maclaurin series, and the number of example we solved guys. Hence today's session is completed here, and Maclaurin series, this point is also covered in this session. Now it is sufficient for today guys. Thank you.